Good morning, students. This is my second video lecture on continuity and differentiability. In previous class, we have discussed some questions. Here again, continue with some question. Here f(x) equal x minus integral part of x. We have to check the continuity of function at x equal to minus 1. We know x minus integral part of x equal to fractional part of x. Here left hand limit of fx x tends to minus 1 minus 1. Limit h tends to 0 f of minus 1 minus h. Limit h tends to 0 minus 1 minus h minus integral part of minus 1 minus h. From definition, minus 1 minus h, that is, this is 0 minus 1 minus 1 minus h, means number lying between minus 2 and minus 1. So its integral part will be minus 2. So minus 1 minus h and this portion equal to minus 2. So minus 1 minus h plus 2. Limit h tends to 0, 1 minus h tends to 0, result will be 1. Again right hand limit of fx x tends to minus 1 plus. Limit h tends to 0, f of minus 1 plus h, minus 1 plus h, minus 1 plus h, minus 1 plus h means minus 1 plus something, number lying between here. So integral part again left in minus 1. So this part equal to minus 1 and minus 1 into minus 1 plus 1. So this term will cancel out and limiting value will be 0. F of minus 1. We know fractional part of x. F of minus 1, fractional part of x, when x is integer, will be 0. So f of minus 1, fractional part of minus 1 equal to 0. So here L equal to 1, not equal to R, 0, but value 0. So function is not continuous at x equal to minus 1. Here right hand limit and value both are equal. So we say here function is continuous from right. If left hand limit and value will be equal, then function is continuous from left. If right hand limit and value equal, function is continuous from right. Here function is continuous from right, ultimately function is discontinuous at x equal to minus 1. We can also visualize this question by graph. We draw the graph of fractional part function. We know fractional part of x always lying between 0 to 1, including 0. We first draw the graph y equal to 0, that is x-axis, and y equal to 1, this line. We know graph 0 to 1, 1 to 2, 2 to 3, so on. These are the portion of graph between 0 to 1, 1 to 2, 1 to 3. Similarly, minus 1 to 0, minus 2 to 0, so on. We have to test the continuity of function at minus 1. Obviously, x approaches to minus 1 from left. X approaches to minus 1 from left. Corresponding value of fractional part approaches to 1. So left hand limit is 1. When x approaches to minus 1 from right, in such case corresponding value of y, that is fractional part of y, tends to 0. This line regularly becomes 0. So right hand limit here equal to 0. Again here we take close point at minus 1, function will be 0. So clearly function is discontinuous at x equal to 0. Here a general impression, a fact about piecewise defined function like greatest integer function, fractional part function, least integer function, These functions are everywhere continuous except integral point. So in objective question, we directly say here function is discontinuous at x equal to -1 because x equal to -1 is an integer. Now we take next question. If fx equal to log 1 plus x square tan x upon sin x cube for x not equal to 0 is continuous at x equal to 0. Here given that function is continuous at 0, find f0. Since function is continuous at 0, so existence of limit left hand limit, right hand limit, both are necessarily equal. Here existence of limit assured, so there is no need to find separate limit left hand limit, right hand limit. We simply value of function equal to limit fx x tends to 0. We directly take here function limit x tends to 0 log 1 plus x square tan x upon sin x cube. Now we use a result limit of log 1 plus phi x upon phi x tends to 0 equal to 1. This is a general result we have already studied in limit chapter. In particular case, log 1 plus x by x limit x tends to 0. Here, when x tends to 0, this factor tends to 0. So, 1 plus x square tan x 1 plus phi x by phi x. Here we write x square tan x in denominator and multiply x square tan x in numerator. We adjust tan x by x in denominator, x in numerator, so that tan theta by theta tends to 0 and theta by sin theta tends to 0 are used. So clearly x square into x cube. This x cube upon sin x cube, theta by sin theta. This will be equal to 1 and tan x by x equal to 1 when x tends to 0, or log 1 plus phi x by phi x tends to 0, 1. So this factor 1 and tan x by tan x 1 into 1 into 1 equal to 1. So f of 0 equal to 1.